Hi, in this video, I'm going to talk about configuring and verifying RIP version 1. So here's our chart of dynamic routing protocols, and we see RIP version 2 there for IPv4 and RIP-NG next generation for IPv6, but we don't see RIP version 1. Okay, let's talk a little bit more about this here. RIP version 1 is what's known as a classful routing protocol. I'm not going to get into the specifics of this, but in a classful routing protocol, routing protocols do not send the subnet mask in the update, just the network address. This is back in the days when you got a Class A, Class B, or Class C address shown in the range there, you had the entire address itself. So if I received a Class B address, let's say 172.16.0.0, which by the way is a private IPv4 address, but using this as an example, that's a Class B address, a /16 mask. That means I would have that entire /16 address space and nobody else. So routers, either RIP routers, RIP version 1 or other classful routing protocols, either assumed the default classful mask or applied a mask of the interface. I won't go into the details here. It's probably more detail than I need to go into. Anyways, but I do wanted to mention what RIP version 1 is. And if you're going to use RIP, definitely don't use version 1. Use version 2. But the basic configuration is the same. So let's get into it. So first of all, why are we even using RIP? It's not used in any modern networks today, but it is a nice little protocol for understanding basic routing. A lot of the concepts we see here for configuration will apply to other routing protocols, and I'll mention those as we get there. And so here we're just going to show a brief overview how to configure basic RIP settings and verify RIP. Okay, I want to mention that there's several sites out there that give you some nice little summaries or what they call cheat sheets. Packetlife.net has these nice little cheat sheets you can download in PDF format for various routing protocols and other things as well. So you may want to check that out. So here's the topology we're going to be using. So if we look at router R1, it has a gig 00 interface on the 192.168.1.0 network, and also has an interface on the 192.168.2.0 network. Okay, and so just go through these here. You can see the different networks that each router belongs to. Okay. And that's key. Initially, the only thing routers know when you configure the IP address and subnet mask on the interface, and if the interface is up and up, it knows that it belongs to that directly connected network, but doesn't know about any remote networks. Okay, so let's go ahead and configure RIP. So it's very easy. We just global configuration mode, you say router RIP. All right. And we'll see this as you do this for both version 1 and version 2. We'll talk more about that in a moment. The default is RIP version 1. All right, so router RIP, if I did a question mark here and looked at the some of the configuration commands under router RIP configuration mode, there's many, I haven't listed them all. In red are some of the key ones we're going to be taking a look at in these RIP configuration videos. Okay, so how does a router enable RIP in iOS, or how do we enable RIP on the iOS? We go router RIP, and we use a statement called the network statement. And all we have to do for RIP version 1 is say network, then give the network address. Okay, so here we're actually given the classful address, which works for both RIP version 1 and RIP version 2. So here we're saying network 192.168.1.0 because it belongs to the 192.168.1.0 network. We also say 192.168.2.0. Now, in RIP, we don't have to give the subnet mask or also a wildcard mask as we do in other routing protocols, but we'll talk about those when we get there. We just give the classful address in the network following the network command. What this says is any of my interfaces that have an address that falls under the 192.168.1.0, in this case, would be a /24. But so here we have a /24 that falls under the 192.168.1.0. 192.168.2.0 is also a class C network. So its mask is /24, but this is a /30 interface. It falls within that range. So what these network statements mean is, do I have any interfaces that fall under these classful range? R1 has 2 interfaces, 1 for each, which is why we're giving these network commands. So what does this network command do? Well, it does 2 things. It enables RIP on all interfaces that belong to that specific network. What that means is that it will now send and receive RIP messages on those interfaces. It also means it will advertise these network addresses that are on these interfaces. It will advertise those networks as RIP routes to its neighbors. All right, we're going to do the same thing on router R2. And we're actually have to do 3 networks here so we're giving the classful address of all 3 of its interfaces, 1 for each. And we're doing the same thing for R3. Now, don't get caught up on the classful, having to put in a classful address. This is really something specific to RIP. And when you, in other routing protocols like EIGRP and OSPF and ISIS, we actually will give the specific network address and subnet mask of the interface. All right. So on R1, if I do show IP protocols, this will give me some information. It'll tell me that I'm now running, or that the router is now enabled for RIP, the dynamic routing protocol RIP. RIP sends updates every 30 seconds and is expecting the next one is going to be sent in 16 seconds. Here's some different timers that RIP uses: invalid, hold down, and flush timers. There's some information there if you're really interested. I used to go into these in a lot more detail years ago when RIP was a little bit more predominant out there, or when it was actually used a little bit more, but now it's just really not necessary. You're not going to really run, if you run into RIP out there, in any kind of network that's more than just a handful of routers, and you should replace it with something else like EIGRP, for example. Anyway, it says that we are running RIP version 1. It shows the interfaces that we've enabled RIP version 1 on. It says automatic network summarization is in effect. We'll talk about this in a later video. Maximum path, this means the number of equal cost paths by default. So if RIP version 1 had 4 neighbors that all had a equal cost path to the same network, 4 different paths, it could use up to 4 of them. Okay, it says which networks this router happens to be advertising, the ones that it's directly connected to. It says it has a neighbor at 192.168.2.0, and last got an update from this neighbor 15 seconds ago. The distance that is shown there and also here that's the administrative distance. That's not a routing metric. So RIP, both V1 and V2, has an administrative distance of 120. All right, let's verify that now that we've configured a RIP version 1 on all 3 routers, do we see those remote networks? So let's take a look. And yes, router R1 sees the 3 remote networks on via router R2. All right, and to show IP protocols command on R2 gives us similar information that we saw in R1. If we do show IP route on router R2, we see its remote networks, one via R1 and one via R2. Okay, we see both the next hop address and the exit interface. Okay, show IP protocols on R3 says it shows us similar information, and if we do a show IP route on R3, we see the remote networks, all three via router R2. Okay, and show IP protocols on R1. Once again, I want to just mention it does show that we are running RIP version 1, which by default is the version when you enable RIP. In the next video, I'll show you how to enable RIP version 2 and why if you're going to run RIP, definitely run RIP version 2. It is what's known as a classless routing protocol, which is what all routing protocols are today. All modern routing protocols are today. Okay, that's it for RIP version 1. We'll learn more about RIP version 2 in the next video.